Good afternoon, everybody. I'm going to talk to you for the next 15 minutes or so on Narec. I'm going to give you a brief overview for those of you who are not familiar with us or haven't had an update recently. I then want to talk somewhat generally about the importance of innovation in stepping up offshore wind. That's absolutely critical. And then I want to hone in on really Narec's role in that. Our specialism is going to be full-scale testing in a controlled testing environment. So I'll talk a little bit about that, and then I'll conclude by giving you an update on the infrastructure build. We are probably now the world's largest renewable offshore integrated testing facility, and there's been close to £150 million of mainly state investment in our campus, so it really is a very big project. So a quick visual, here's who we are. I'm Scottish, but we're located just over the other side of Hadrian's Wall in Northumberland and Blythe. We cover all of the offshore renewable energies. This is a visual of the campus. If you look down to the left, there's an electrical material testing laboratory. It's built around our former dry docks, which forms our marine test site. You've got tidal drivetrain testing, and then to the top of the slide, the main body is the original Blythe wind testing facility, our new 15 megawatt drivetrain test rig, which I'll talk more about in detail. And at the very top is our 100-meter blade test facility, which will be the largest blade test facility in the world. So I think we've talked quite a lot about cost reduction, the importance of it, and there's plenty of literature and task forces that have really pointed that out. And one of the, I guess, critical items in that was the creation of a pay-as-you-go test facility. There's a huge fixed cost to putting these facilities in place, and one of the things we hope to lower barrier to entry to the market is really to make this a pay-as-you-go. So if you don't need it, you don't use it, but it's there as and when you need it. So stepping up offshore wind really is a serious step. It's a leap. It's not just about the upscaling of onshore technologies. It's a whole new domain. And I think this visual really gives you a sense of scale as to where we think the industry is going. You can see the comparison with an Airbus 380, but really it's looking at supersizing traditional technologies, and that's going to push engineering and materials to their absolute limits. And in order to be able to do that, you have to have a commensurately supersized scale of testing facility, and that's what we're building at Narec. So here's a sort of traditional innovation curve. We don't attempt to replace learning by doing. Learning by doing an in-field commercial deployment of offshore wind arrays, demonstration sites is absolutely paramount. But what we hope to be able to do is to provide a supplementary testing regime which is onshore in a controlled testing environment. And we think that can significantly scale down, can reduce cost and make support the market growth. So here's a traditional bathtub curve. There hasn't been analysis of offshore wind turbines. There isn't enough data there yet. But if you look at the life cycle of a traditional onshore turbine, a huge number of failures occur early in the lifespan. So if you can get the turbine, the teething errors down, it really gets the life cycle of the turbine off to the best possible start. And if you can do that onshore with the prototypes and get it right with one turbine, it then puts you in a much better position when you start mass manufacturing. So it's costly to make mistakes with prototypes, but much better to identify them at an early stage. So just flicking on to the next slide, this really tells you what we're trying to do, which is highly accelerated lifetime testing. If you think about it, a lot of stress on the offshore wind turbines occurs during extreme moments. So that could be an extreme storm, or there could be some event on the grid which causes the turbine to switch off. So if you have a controlled testing environment which can essentially take out all of the calm and boring days, and you can compress together those extreme cycles, then you have a way, and it's by no means an exact science, but you really have a way where you can understand and capture data on your turbine in a relatively compressed time period. And I think that's of profound interest to the manufacturers, the OEMs, but all of this is about building business confidence. We don't have 20, 25 years to wait to see how these turbines will perform. The OEMs have got an interest, but the customers have got very big purchasing decisions to make as well. So they need to understand the turbines that they might be buying, as to the banks who are lending against these, and also the insurers. Everybody has a common interest of business case certainty. So where do we fit in? And I think this probably segs in quite nicely with Terry's slide. We see there's obviously the TRL on the left-hand side, and we really see this as a big leap to make between your scale testing, your initial R&D design, and then putting a full-scale device in the water. We don't see that as a step, but a series of steps or a leap, and that's really where Narec is trying to help the industry. So component validation, and I'll talk a little bit more about the new facilities on that in a moment. Subsystem validation, full-scale, integrated, repeatable, realistic, the points I've touched on before. Principally the 15-megawatt drivetrain test rig, which I'll outline shortly. And then I'll touch a little bit on the offshore demonstration site. I won't spend too much time on that, but I'll just give you a brief update. So perhaps often overlooked is our marine test site. This is, I guess in some ways, a beating heart of Narec. And what you've got here is a series of former dry docks, which was actually used initially in the 1980s by British Gas, who were incurring huge offshore costs, DP vessel, dynamic positioning vessel hire costs, when they were installing offshore pipelines and technologies. And they really decided they had to do something about it. And what they decided to do was to test all of their components, all of their pipelines and connectors, and also the installation and decommissioning and maintenance techniques at the same time. And what they found they could do was significantly reduce DP vessel hire time. And that's a very relevant industry to offshore wind as well. If you can get these techniques and these components right on the balance of plant, so cables, ploughing techniques, wet mate connectors, J-tube connectors. We see a lot of trials going on here of the components, but also EPIC subcontractors who want to get full confidence that they can minimize the installation cost and rig installation cost and time ahead of actually installing. So we've seen some very interesting trials, for example, on the London Offshore Wind Array project take place here. Now to blade testing. This is a visual of our 100-meter blade test hole. So this will be, it's currently being commissioned, but this will be the world's largest blade test hole. We currently have, our existing facility can test blades of up to 50 meters. But one of the engineering challenges when you're building facilities like this is we not only have to be able to accommodate the blades which are in the market now, but we have to make an educated guess as to where we think the blade market's going. Clearly, there are no blades at the 100-meter mark now, but we think it's perfectly possible that they could get there. And if they do, then there needs to be somewhere to test them. So the envelope of this building has been very much built with not just the present in mind, but the next 5, 10, and 15, 20 years. So just to give you a size, a sort of impression of the scale of this, and this really drives home just how much bigger these turbines are going to be. This is looking from the main hub onto which these blades are attached and to which they're tested. You can see that the hub at the right-hand side, that's looking at it from inside. But you can see down the test hole, and in this hole they will actually be able to bend these blades by up to 50 meters. So there's immense forces running through that hub. Just to put it in context, that hub is designed to withstand a maximum bending moment of about 200 meganewton meters. In a sort of layman's context, if you were to have a plank a mile long and you were to drop 3 elephants on the end of it, and the other end of that plank was attached to the hub, that's a reflection of the size of the forces. I stress that's a theoretical calculation. If there's any animal lovers out there, that's never actually been done, but it gives you a sort of sense of just the size of forces going through it. So we can carry out fatigue testing on there, where we vibrate the blade for anything up to 2 to 3 million cycles. We also do static testing, where we bend the blade, and all of that puts in place the program you need to go through to certify the blade. So it's a very big part of getting these big blades properly certified and out into the market. So moving along the TRL curve, I've talked a little bit about sub-assembly systems, subsystems. Principally at Narec, we're talking about drivetrain testing. This is actually a Tidal drivetrain test rig. I'll come on to its big brother, the 15 megawatt offshore wind one, in a moment, but I think the visual sort of describes, tells you how it sort of works. So on the right-hand side, what you've got is a nacelle that's had the blades taken off. On the left-hand side, what you've got is a prime mover, in this case a 3 megawatt motor going down through a 30-to-1 gearbox reduction. That provides a torque, and the torque is, of course, what all generators are all about. The more torque, the more electricity can be produced. That's what generates you your money. The box in the middle is a force application system, and the force application system is there to apply axial and thrust loadings, axial thrust and radial loadings. And what that means is that you can apply loads pretty much in 360 degrees on the shaft. And unfortunately, wind isn't like a wind tunnel. It's extreme amounts of shear, blustery wind conditions, and analysis of onshore wind turbines has showed that one of the biggest sources of in-field failure, particularly early in life, is these off-axis loadings. So what you can do here is take the real weather conditions, program them into the computer, and this will take you through those events. So this is its big brother. It's a 15 megawatt nacelle motor. I think it will probably be the biggest one in the world when it's complete. So just like the previous one, but on a much bigger scale. There's no gearbox. It's a direct drive model. The maximum bending moment that this will be able to impose on the shaft is 56 meganewton meters. So again, it's a very, very big piece of kit. If you just move on to the next slide, that's probably the most recent publicly available picture of the build-out project. So the actual building is now complete. We are very close to the final installation phase, and we hope the first commissioning test is probably due to commence mid-summer. So it's approaching a sort of very exciting point in the build-out program. Just like to conclude with a short update on the Blythe offshore wind demonstration project. For those of you who don't know, this is we put in a planning consent for a 99.9 megawatt site. If you go over that, it becomes a commercial array, and it becomes a slightly different process. Narec were funded by the state to essentially go through the consenting process, put in place a power purchase agreement and an onshore substation. So essentially to try and take some of the headache out of that. So we were granted a lease by the Crown Estate, and the plan is to have 15 pods spread across 3 arrays at distances of approximately 5, 7, and 14 kilometers from the shore. So 35, 45, and 55 meters of water depth. Those sites have deliberately been chosen to be representative of round 3 conditions. In terms of process, we are due reasonably imminently to submit the supplementary EIA, so we've been through most of it now. We're hopeful of a positive response. We remain within the procurement process and with the incumbent bidder, and there's reasonably advanced and positive discussions going on over the consortium structure. So the maximum tip height that will be allowed on that if it goes ahead will be 195 meters. So really able to accommodate hopefully this generation and the next generation of offshore wind turbines. I'd like to just finish by just talking on the fixed anemometry hub which we have which is the first tangible visual signs. If you're driving up past Newcastle, you can see it now out to the ocean. I think this really is a good example of how you can use Narec to reduce offshore wind costs. We had to put this in as part of our planning process. This offshore anemometry hub measures over 106 meters from the seabed. It cost over £20 million, and it has a very sophisticated environmental monitoring tools on it. Now, that's very, very expensive, and one of the programs that we've just launched is a floating LiDAR verification service, where the next generation of floating LiDARs, which have none of the associated costs, can be positioned next to it, and they can use this anemometry hub as a reference point, because one of the challenges of floating LiDAR is they're bouncing up and down in the water, and they have to have the data verified to make sure that it's accurate. So this, again, is a sort of tangible example of how we can help offshore wind step up to the next stage. That's really it from me, so thank you very much.
Thanks very much, John. Some impressive facilities at Narec, I think you'll agree. It's sort of nicely, having had the 4 presentations, that last one really, the issue about component and sub-assembly testing in those rigs that we saw, the Fujian rig, the Blythe test rig. Accelerated life cycle testing must be more cost effective than full scale in the water. Faster proving of these products can help to meet those 2020 targets that we're all aiming for by providing confidence in those new products quicker than would otherwise be the case. And it's certainly true that when you look at the developers, the new finance that's going to need to come in, the billions of pounds in those new projects, that new finance will not be familiar with the technology. They will need that evidence provided by that those products going in are going to last 20 years and going to be reliable and efficient, etc. I think foresight is the other thing. The statement about the 100-metre long blades, for those of you who listened to Ben Sykes this morning from Dong talking confidently about their pipeline, he said 8 to 10 megawatts, 200-metre rotor diameter. That's a 100-metre long blade. So it can't be that too far away. And when you look back at the history, certainly of onshore wind, people said, we'll never have a 45-metre blade, and yes, there was a 45. Well, we'll never have a 60-metre blade. There's a 60-metre blade. Technology is the thing that drives us forward, and we can never say never. So I think foresighting and looking to the future are very important for these facilities. I think just lastly, that physical size. We are in a new paradigm with offshore wind. The physical size of those facilities, driving those nacelles round from that test rig, it's just enormous. It's not like onshore wind. We are moving into a new phase. So with that, are there any specific questions for John around Narec before we open up to the floor for general questions?